700 microstrain. Now, once again, this is the industry average. So when we're testing Carl's system, the morning before he showed up, I had pulled this data off, and as we're running these tests, I'm looking and seeing where is the composite sleeve in each of these tests. So the first test that we run is the steel only. Well, you might be able to see it there, but the strain that we got to was about 2,200 microstrain. So it was half what everybody else is doing just with the steel by itself, okay? And then when you look at the 8-wrap system, it was at 1,600 microstrain. So it's almost a third what we're seeing in the industry average. Now, the previous slide, which is probably going to be hard for you to see, is basically we plotted strain versus pressure. And once again, you'll get the report so you can kind of look at this. But what you see is a perfect piece of pipe. These repairs are much closer to the perfect piece of pipe than what we're seeing with the other composite systems. And once again, I think the whole key is the fact that you're putting steel on steel. Whether it's a wrinkle bend, I know Carl may wind up talking about some of that, but you got wrinkle bends, I've got girth welds, I've got corrosion, I've got dense mechanical damage. These are real anomalies that we have to deal with in the pipeline industry. We've got a couple of choices. You either derate the pipeline, cut out the section, which a lot of pipeline companies do. It's a very conservative option. Or I have some kind of repair on there. One of the last things I'll mention before I finish, we're doing a PRCI project looking at dents and primarily focused on looking at composite materials. So I think we tested 7 or 8 different systems. The results have been generally very, very good. Most of these composites have increased the fatigue life from about 7,000 or 8,000 cycles all the way up in excess of 250,000 cycles. But I was at a meeting, and one of the guys who's kind of a steel sleeve guy said, I wonder how steel sleeve would do in all this. I said, well, let's run a test. So PRCI gave us some additional funds to test this, so we welded some steel sleeves on there. Type A, we didn't weld the ends up, and we pressure cycled. Now the amazing thing to me was I expected the steel sleeves to run out to 250,000 cycles and to be just as good as the composites. Actually, that wasn't the case at all. Probably the average cycles to failure of these 6 dents was about 20,000 cycles. So one of the things that it reinforced to me, and they had a filler material in there, is that these systems, and I think the composite sleeve would fit in this camp, but certainly the composites, they get a very intimate bond to the pipe. And those straps that you're going to see Carl and Rich, everybody put on, it really makes sure that you cinch down to the pipe, and that's critically important because if you don't get a good tight fit up, what happened with these steel sleeves that we put on there, they just had flexure that went on underneath. And we did put a filler material on there that's used by several of the gas companies. So at the end of the day, I think there's things as an industry that we've just done for years and we've assumed that it works because we've never had a problem. But when you start testing these things, you really find out how good the performance is. And here's the last slide. So, I think in large part across the United States, and I was in Europe last week and talked about composite materials, I think across the world composites are really, they've gained acceptance. I mean, in my career over the past 15 years, when I first started, people wouldn't even really look at composite materials, but I think they've realized that there's some real legitimacy. And really, the composite sleeve combines the best of both worlds. You've got the flexibility that you have with the composite materials, but you've also got the strength and the stiffness of steel. So that's, one of the advantages of this system. And one of the critically important things for me when I look at the test data is how much does the strain or the stress reduced underneath the repair. That's the reason you get to, almost 800,000 cycles is the fact that you've got a lower strain in that corroded area. And then the last thing is, it can be engineered. And as I said, Carl and I talked quite a bit, and he's usually got some new application that's driven by the fact that pipeline company has a problem, and that they want to talk to Carl about how can we design a solution to make this problem go away. And I think as you see from the test data here, that's certainly a possibility.